Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to discuss about theories of acids and bases. Mostly we will explain three theories of acids and bases. Firstly, we will discuss Arrhenius concept of acids and bases. And second, we will discuss about Lowry and Bronsted concept of acids and bases. And third one theory that we will discuss is the Lewis acids and bases theory. According to the concept of Arrhenius, an acid is a substance when dissolved in water, it produces hydrogen ion. That how an acid produces hydrogen ion. Most important thing is that why hydrogen ion is lost from the acids. As we know that the most of the ionic substances are polar in nature, having positive and negative poles. So when they dissolve in water, they produce positive and negative charges. As the most of the acids contain hydrogen atom, and hydrogen atom have partial positive charge, and the other part of the acid may be a halogen, it may be a nitrate, or it may be a sulfate, such as in halogen acids HCl, HF, HBr, HI, such as in sulphuric acid H2SO4, or such as in nitric acid HNO3. So the acids may be monoprotic, diprotic, or triprotic, depending upon the number of hydrogen atoms present in the formula of acids. So how an acid is dissolved in water? The basic concept is the hydration of the substances. What is hydration? Hydration is the substances polar substances when dissolved in water, they are surrounded by water molecules. As we know that water is polar in nature, so the polar substances dissolve in water. Polarity is the main cause due to which the concept arises, the like dissolves like. The polar substances are dissolved in polar solvents, and the non-polar substances are dissolved into the non-polar solvents. So when hydrogen ion is produced, an acid is dissolved into water, the hydrogen ion is produced. But the hydrogen ion cannot exist independently in the water solution. Why? Because when hydrogen loses its only one electron, it has only one proton left into its structure. If we look at the structure of the water molecule, oxygen contains 2 lone pairs of electrons and 2 hydrogen atoms covalently bonded with it. So the size of the hydrogen atom is the smallest of all elements present in the periodic table. As the only electron is left from the hydrogen atom, only proton attracts the lone pair electrons present in the water molecule that are on the oxygen atom. So So a coordinate covalent bond is formed between hydrogen ion and the water molecule. So the new type of ion is found, that is hydronium ion H3O positive ion. Remember, however, the aqueous hydrogen ion is actually chemically bonded to water. So hydrogen ion or proton doesn't independently exist into the water solution. According to the Arrhenius concept of acid and bases, a base is a substance that when dissolved in water, it increases the concentration of hydroxide ions. Most of the bases contain a metallic positive part and a hydroxide ion. That was the concept of Arrhenius acids and bases. Now the second concept of acids and bases theory was given by Lowry and Bronsted. According to the Lowry and Bronsted theory, an acid is a proton donor and a base is a proton acceptor. So what is the condition of acid? It must donate a proton to a base to become an acid. So the base must contain a lone pair of electrons to accept a proton from an acid. Likewise, we have discussed hydrochloric acid. When hydrogen ion is lost by the HCl, the lone pairs of electrons present on the water, they make a coordinate covalent bond. So the primary requirement is that the base must contain a lone pair of electrons to accept a proton. The conjugate base of an acid is the species remaining after the acid has lost the proton. Such as in this example, we can see that HCl, when reacts with water, the HCl is an acid that gives a proton, and water is the base that accepts the proton due to the lone pairs present on the oxygen atom. So resulting water is a conjugate base of hydronium ion and chloride is the conjugate base of hydrochloric acid. Water can both act as acid as well as base. That is, it is amphoteric in nature, having both properties of acids and bases. Strong acids have weak conjugate base, and weak acids have a strong conjugate base. Such as ethanol is a weak acid, and its conjugate base hydroxide ion is a strong base. That is, it can accept readily a proton. Bases can donate a pair of electrons. According to the Lewis acid and base concept, there is a third theory that we are going to discuss is the Lewis acid and base theory. According to the Lewis acid base concept, a base is a substance which can donate a pair of electrons. And according to this concept, an acid is a substance which can accept a lone pair of electrons. Many Lewis acids don't contain hydrogen. So what is the primary requirement of this acid-base concept? A pair of electrons, a donor and acceptor. Pair electron pair donor and electron pair acceptor model. What are the properties of acids and bases? If we look at the properties of acids and bases, neutralization is a chemical reaction that generally occurs between acids and bases. What happens when neutralization occurs between acid and bases? Look at this. Here, acetic acid when reacts with sodium hydroxide base, the resulting product is formed sodium acetate, a salt plus water, with metal oxides to form a salt and water. When sulphuric acid, here in example, reacts with copper oxide, it forms copper sulphate and water. With ammonia, hydrochloric acid reacts to form ammonium chloride as salt. With reactive metals such as magnesium, hydrochloric acid reacts to form magnesium chloride as salt, and hydrogen gas is liberated in this reaction. With carbonates to form salt, carbon dioxide and water. HCl is a strong acid that reacts with calcium carbonate to form calcium chloride, a salt, plus carbon dioxide, a gas, and water. With halogen carbonates to form salt, carbon dioxide and water. Hydrogen chloride reacts with sodium bicarbonate to form sodium chloride, carbon dioxide and water. Strong acids and bases are completely dissociated into ions, that is, they are ionized into the aqueous solutions. The examples of strong acids are hydrochloric acid, nitric acid, sulphuric acid. As we know that they contain a conjugate base, that is a weak base. Chloride is a weak conjugate base of hydrochloric acid. Nitrate is a weak conjugate base of the nitric acid. Sulfatine is weak conjugate base of the sulphuric acid. Strong bases, here we show example sodium hydroxide, potassium hydroxide and barium hydroxide. These all mineral bases are strong bases, that is, they when dissolved into water they are completely ionized into their metallic ions and hydroxide ion. Weak acids and bases are slightly dissociated into their ions in aqueous solution, while weak acids when react with a base, their conjugate base is a strong base. So the condition of reversibility to form the native acid is more in this case. Weak bases such as ammonia and aminoethane. Ammonia is a weak base and the basicity in the amine bases increases when the alkyl groups increase on the nitrogen atom of ammonia. Acidic oxides are the oxides of nonmetals when combined with water to produce acids. For example, acidic oxides are therefore known as acid anhydrides. For example, sulfur dioxide reacts with water to form sulphurous acid. Sulfur trioxide reacts with water to form sulphuric acid, and carbon dioxide reacts together with water to form carbonic acids. Likewise, there are basic oxides. Basic oxides are oxides of metals. If soluble in water, they react with water to produce hydroxide alkalis. As we know that alkali metals and alkaline earth metals are basic in nature. When they react together with water, they form a base. Such as calcium oxide reacts with water to form calcium hydroxide, or sodium oxide reacts with water to form sodium hydroxide, or magnesium hydroxide reacts with water to form magnesium hydroxide. Besides from acidic and basic oxides, there are amphoteric oxides. Means they can behave as an acidic oxide, or they can behave as basic oxide. One other example of the amphoteric oxide is zinc oxide. Zinc oxides, when act with a base such as monoxide, it behaves like an acidic oxide, and the product formed is sodium zincate in water. Likewise, when zinc oxide reacts with hydrochloric acid, it acts as a basic oxide to form zinc chloride and water. There are some neutral oxides. These are the oxides which show their basic, they are not basic nor acidic properties. That is, they don't form salts when react with acids or bases. Neutral oxides are carbon monoxide, nitrous oxide, nitric oxide, etc. Thanks. If you have any question from this lecture, please feel free to ask. Thank you very much.